In May 1970, a team of engineers at Rolls-Royce prepared for a standard yet incredibly brutal mandatory certification trial. They were testing the RB211 jet engine, a massive machine meant to redefine the economics of commercial aviation. For this specific test, they fired a bird directly into the engine's enormous rotating fan, simulating a high-speed mid-air strike. The engine's fan blades were constructed from a revolutionary new carbon fiber material known as high-fill. The expectation was that the advanced composite would slice through the impact, absorb the shock, and keep the engine running smoothly. Instead, the high-fill blades catastrophically shattered. It was a total failure of the engine's most critical component. But this single event in a British testing facility was far more than an engineering setback. The shattering of those carbon fiber blades triggered a massive financial death spiral. It would force Rolls-Royce into voluntary receivership, threaten to completely bankrupt the American aerospace giant Lockheed, and compel the highest levels of the British and United States governments to intervene just to keep the commercial aviation industry from unraveling.
To understand how a single engine part could threaten two international economies, we have to look back to the late 1960s. The commercial aviation market was racing headlong toward the era of the wide-body airliner. In the United States, Lockheed Aircraft Corporation, a massive American defense contractor, was developing its own entry into this highly lucrative market, the L-1011 TriStar. They needed an engine that could deliver unprecedented thrust to lift the massive airframe while remaining incredibly fuel efficient for airline operators. Across the Atlantic, the iconic British aerospace manufacturer, Rolls-Royce, believed they had the perfect solution. Their chief engineer, Adrian Lombard, was a visionary who championed a highly advanced three-spool engine design known as the RB211. To meet the incredibly demanding weight requirements for the TriStar, Lombard pushed for the use of high-fill, an experimental carbon fiber composite, for the engine's enormous fan blades. It was a brilliant, bleeding-edge concept designed to undercut the competition on weight and efficiency. But in July 1967, Lombard died suddenly. His passing left a critical technical and leadership vacuum at Rolls-Royce, right at the dawn of the engine's incredibly complex development cycle. Despite this massive loss, the managing director of the Aero Engine Division, Sir David Huddy, pushed forward, aggressively lobbying Lockheed for the business. In March 1968, Huddy successfully secured the exclusive contract to supply the RB211 for the TriStar airliner. However, to win the deal against fierce American competition, Rolls-Royce agreed to a fixed-price contract. They promised to deliver a revolutionary, technologically unproven engine design at a set cost, absorbing all the financial risks of the unknown development themselves. The exact financials of this era remain a subject of historical contradiction. Initial research and development cost estimates, before any overruns occurred, varied widely in the records, sitting somewhere between 65 million and 85 million pounds. Even the exact pricing of the final contract itself is disputed by historical sources. Contemporary figures from 1971 cite a deal of $156 million for 540 engines, while other, later historical records point to a price of £230,375, or roughly $840,000 per engine. Regardless of the exact figure, the structure of the deal was set in stone. Rolls-Royce was entirely on the hook for the price of inventing the future. With the exclusive fixed-price contract signed in 1968, the pressure inside the walls of Rolls-Royce was immense. They were essentially racing against the clock and their own balance sheet to invent material science that did not fully exist yet. The leadership vacuum left by Adrian Lombard's death was becoming increasingly apparent as the engineering teams struggled to translate his visionary three-spool design into a reliable working machine. By the autumn of 1969, the warning signs were flashing red. Testing on early prototypes of the RB211 revealed that the engine was significantly overweight, and worse, it was missing the thrust guarantees required by Lockheed for the TriStar to fly properly. The carbon fiber high-fill blades were supposed to be the magic bullet that saved weight and improved efficiency.
But manufacturing composite blades that could withstand the extreme, sustained aerodynamic forces of commercial flight was proving far more difficult than anticipated. Every delay, every failed prototype, and every hour of extra engineering ate directly into Rolls-Royce's margins because of that fixed-price agreement. They could not pass a single penny of the escalating development costs on to Lockheed.
Then came May 1970, and the mandatory bird ingestion certification test. When the carbon fiber blades catastrophically failed and shattered under the impact, Rolls-Royce lost its biggest technical gamble. A commercial airliner simply cannot be certified to fly if its engines disintegrate upon hitting a bird. They could no longer rely on the experimental high fill. The only viable alternative was to immediately revert to traditional titanium fan blades. But in the world of high-performance aerospace engineering, changing the material of a massive rotating fan blade is not a simple swap. It triggers a vicious chain reaction. Titanium is significantly heavier than carbon fiber. Installing heavier blades meant the rotating mass of the engine increased dramatically. To safely contain that extra kinetic energy and support the heavier fan assembly, the outer casing had to be thickened. The internal shafts had to be reinforced. The bearings had to be enlarged. Reverting from high-fill to titanium required a total structural redesign of the RB211 engine. The engineering cascade was devastating, and the financial toll was terminal. By September 1970, Rolls-Royce was forced to report to the United Kingdom government that the development costs for the engine had reached a staggering £170.3 million, vastly exceeding the most pessimistic initial estimates. While Lockheed celebrated the successful first flight of the prototype L-1011 TriStar on November 16, 1970, the engine powering that very aircraft was rapidly sinking its creator.
The stark financial reality finally caught up with the engineering delays. On February 4, 1971, Rolls-Royce Limited, a towering icon of British engineering and industrial might, voluntarily entered receivership. They were entirely bankrupt due to the escalating RB211 development costs. The collapse of Rolls-Royce was an unthinkable shock to the global aerospace industry. Because they held an exclusive contract for the L-1011, their bankruptcy instantly threatened the survival of the Lockheed Aircraft Corporation. Lockheed had an airliner essentially ready for market, but absolutely no engines to power it, and no alternative supplier whose engines would fit the uniquely designed TriStar airframe. The crisis demanded immediate, massive government intervention on both sides of the Atlantic. In the United Kingdom, Prime Minister Edward Heath and the Conservative Party government had to make a drastic, ideologically painful move to save the nation's critical aerospace capabilities. In 1971, the British government formally nationalized the Rolls-Royce Aero Engine Division, forming a new, state-owned entity called Rolls-Royce 1971 Limited. But nationalizing a British company did not solve the massive problem for Lockheed, who now faced their own imminent financial ruin.
The geopolitical stakes had now reached the absolute highest levels of government. The survival of two massive defense contractors was on the line. According to some historical speculation, the extreme pressure sparked acrimonious, heated telephone calls between United States President Richard Nixon and British Prime Minister Edward Heath. During these calls, Heath allegedly threatened to completely cancel the RB211 project if the Americans did not step up and ensure Lockheed's financial stability. While official government channels firmly denied these high-stakes, hostile exchanges ever took place, the sheer panic in Washington was undeniable. Lockheed's chairman, Dan Houghton, furiously lobbied the United States government for a lifeline to save his company from the fallout. The Nixon administration responded by working to create the Emergency Loan Guarantee Board to backstop the failing defense contractor. The debate in Washington was fierce, as lawmakers argued intensely over the ethics of bailing out a private, massively powerful corporation with taxpayer money. Ultimately, the legislation came down to a razor-thin, dramatic margin. The United States Emergency Loan Guarantee Act passed the House of Representatives by just 3 votes, and it survived the Senate by a single vote. On August 9, 1971, President Nixon signed the act into law, securing $250 million in federal loan guarantees for Lockheed.
With the financial crisis temporarily stabilized by government bailouts, nationalizations, and massive loan guarantees, Rolls-Royce 1971 Limited desperately needed to actually fix the underlying problem, the engine itself. They brought the retired engineering legend, Sir Stanley Hooker, back into the fold to lead the technical resolution. Hooker and his highly experienced team systematically addressed the performance issues, navigating the heavier titanium redesign and coaxing the necessary thrust out of Lombard's complex three-spool architecture. The sheer ingenuity required to salvage the overweight design without entirely scrapping the engine proved that Rolls-Royce still possessed world-class talent, even if their early management of the project had been financially disastrous. It took immense effort and time, but on April 14, 1972, the entirely redesigned RB211 engine finally received its airworthiness certification. Just 12 days later, on April 26, 1972, the Lockheed L-1011 TriStar safely entered commercial service with Eastern Airlines. The story of the RB211 is a stark testament to the immense existential risks of pushing the bleeding edge of material science. Rolls-Royce essentially bet their entire corporate existence on a carbon fiber miracle that simply wasn't quite ready for the brutal, unforgiving reality of commercial aviation. Pairing unproven physics with a rigid, inflexible fixed-price contract created an economic trap that no amount of pure engineering brilliance could easily escape. The shattering of those experimental Heifel blades proves that in aerospace, a single point of failure doesn't just bring down a jet engine in a testing facility. It can topple industry titans, bankrupt legendary corporations, force the hands of presidents and prime ministers, and completely reshape the geopolitical supply chain. It ultimately took two global superpowers, hundreds of millions of dollars in highly controversial government intervention, and the return of a retired engineering genius to clean up the fallout of a single material that couldn't take the hit.